So we found some values here. When theta is pi, then sine of pi, it will be 0. So this guy will go back to 3, right? At 5 pi over 4, it will be this guy, okay? Then sine will be negative. It means that this will be 3 plus 3 times negative square root of 2 over 2, right? And 3 pi over 2, it would be this guy, negative 1. 3 plus 3 times negative 1, it would be 0, right? 7 pi over 4, 7 pi over 4, it will be negative square root of 2 over 2. Again, it would be 3 plus 3 times negative square root of 2 over 2 right here. At 2 pi, sine would be 0. Then it becomes 3. So now let us draw a graph of this guy. And we know that the maximum value of r is 6 here, right? And the coordinate here, remember the theta angle start here at this point, parallel to the x-axis. It is theta is equal to 0. So we start there. At 0, it is 3, right? Suppose this is 3 here. Then and we know that at pi over 2, it is 6. Therefore, the angle theta is pi over 2 will be at this angle, right? Parallel to the y-axis. And again, up to pi, it will go back to 3 here. So the same distance from the origin here, right? And then let us write it 0 here. And then here we know that at 3 pi over 2, it goes back to 0. So it means that let us plot some special point here. At 3 pi over 2, it will be 0 here, right? Okay, we know some special points here. And pi over 4, it will be 3 plus 3 times square root of 2 over 2, right? It is 5.1 something, okay? And 6, the distance will be 6. It will be this much. I'm not sure. We know that the angle pi over 4, it should be along this line, right? The distance now is 5 point something. Let us estimate somewhere here, okay? It's not very accurate, but somehow it should be around here. And at the angle 3 pi over 4, it means that it should on this line. Okay, it has the same values as this guy. So if we count this, then it will be symmetric here. Here, right? The same distance from here to here and here to here. And so on and so forth. So here, see, at pi, it will go back to here. And 5 pi over 4, it is 3 minus this guy. It is 0.8, right? 0.8 is very small. somewhere here. And at 3 pi over 2, it should be the origin at the origin here. And 7 pi over 4, it will go back to this guy. So now we have an idea how it looks like. Let us connect all these. Should be like this, right? It's not a good draw, I think. The 0.5, I'm not sure. Yeah, just estimate. I think 5 should be somewhere here instead. Let us just estimate. You can double check it at home to see how the graph looks like. Here, the coordinate, right? It's not very good, but we know. And if you're drawing on the papers, you can use a rulers. If the distance from here to here is 6 centimeters, you can definitely use a rulers to find the distance from the origin here to here. So anyway, that is the graph of this curve, right? In polar coordinate. Remember, the angle right here along this will be theta is equal to 0. And yeah, let us write them is 3, 0. And here, the angle right here is pi over 2. So now, set up the integral to find the area enclosed by this coordinate. Very important that we can always use the formula. And what is it? Very good. 1/2 r squared d theta, right? The area. Okay. That is the area of this guy. It goes from 0 to pi over 2, continue going this up to pi, and then from pi to 3 pi over 2 to this guy. So it will be from 0 to pi to 2 pi, right? Thank you. Some mistake could be this. So we wonder if we can simply go from 0 to pi and then double that things. Can we do this? And why? Very good. Remember, when it goes from 0 to pi, what is the area of that? The area from 0 to pi, it would be from this guy cover to this point, right? That is where the theta at pi here. So if you do this, the area will be the area of this guy. This part. And you double it, it will be different. Okay? So be careful. If you simply look at the boundaries, the limits here, it does not tell you much about the figure, because that is why we have to plot this curve instead of blinding plug into the formula right here And if we plug into the formula, it will be, and R right here is this relation, right? It is 1/2 of 3 plus 3 sine theta. And they are all square here, perfect square. Don't be confused, okay? So, and compute this will give us the error, the areas. And the function here is simply a function of theta. So this is a perfect square. So you can expand this perfect square. It would becomes a function of theta, right? And review it, how to compute the area here. We have done this before. If you don't remember, you should have known this. And I think the best way is to review it yourself, to compute this integral. Another way to find it, but look at this. Here, the area of the integral here is of the right-hand side, the area part here is the same as the area of the left-hand side, right? Symmetry about the y-axis. But remember, the angle theta will start from here. The corresponding value of this is theta is equal to -pi/2, right? Goes from theta is -pi/2. If you compute this explicitly, it will go up to here to 0 and continue until it's reached theta is pi/2. Therefore, another way to deal with this is double the area from theta is from -pi/2 to pi/2 of this r squared. Okay, you can double check it to see if these two formula gives the same result. They should. That is one way. Can we find another formula to compute this area with different limits of theta? Log in, right? Good. From pi/2 here, if we go up to 3 pi/2, it means it covers from this to here. That is the left side of the cardioid, right? Very good. Okay. I think that's it. Just compute this simple integral. Let us save time for other problems, okay? Good. Is it clear or